Hello everyone. In this video lecture, let us discuss about the topic terminologies and basic structure, feed forward and feedback control theory, synchronous and then multi-variable control system under the unit 1 of control systems. The objective of this video lecture is to understand the basic terminology of control system concepts. First, what is a control system? Before that, what is a system? A system is a arrangements of different physical components connected or related in such a manner so as to form an entire unit to attain a certain objectives. So, what is a control system? It is an interconnection of components forming a system configuration to provide a desired response. So this is a control system. I am giving the input. What is the desired output? So next, what is the input means? It is a stimulus or a excitation applied to a control system from an external source in order to produce the output. So next, what is the output means? It is the actual response obtained from the system. The aim to design a system which gives a desired behavior in a controlled manner. Next, if the focus is an analysis and design to improve the speed of response, accuracy and the stability of the system. So next, what are all the applications for control systems? So for the some of the applications are there. So flight control system is a modern commercial and military aircrafts, unmanned aerial vehicles, so robotics, so remote environment, it can use in the remote environment, example space, sea, non-invasive surgery, etc. So next one is a chemical process control. It regulates the flow rate or temperature and concentration, whatever may be, that will be etc. So next one is a automotive. There is the system is an engine control and then transmission control, climate control. These are all some of the examples. And then communications and networks field is the amplifiers and repeaters. There is a conjunction control of an internet. So next one is the power management for wireless communication, etc. And then many more applications are there. So next one is the comparison between the system and control system. So this is a system. System is nothing but you can provide the input. So the output, it may or may not be desired. So for control system means you are giving the input but having the desired output. So for example, fan. You can take as a fan. In a fan without blade cannot be a system. So because it cannot provide any output. Next one is a closed loop system for in a automobile system. Example I am taking here. So this is a desired course of travel and then this is a driver. Here the steering mechanism. This one is an automobile. Here the actual course of travel and then the feedback to the measurements, visual and tactiles. Not tackles, tactiles. Okay, first driver giving the steering mechanism. So the driver is a controller here. So depending upon the measurement that the sensor measures, so the error will be produced. So depending upon the error, the driver will take a action. So this is where desired direction of the travel for black color. The blue color is actual desired of travel. So the driver uses the difference between the actual and the desired direction of the travel to generate a controlled adjustment of the steering wheels. Okay. So next one is what can we manipulate and what we are trying to control. So what phenomena can have impact on a process that we can measure but cannot manipulate. So first one is what can we manipulate means that is called a manipulated variable. Here the acceleration pedal position, brake pedal position, gear selection, steering wheel positions are the manipulated variable for automobile system. So here this is the acceleration position, brake pedal position, steering wheel positions are the manipulated variable. So next, what is a controlled variable means? So what we are trying to control, that is called the control variable. The speed of the car, distance from edge of the road. These are all the controlled variable. So next, feed forward variable. So what phenomena you can impact on a process that we can measure but we cannot manipulate. So that is called feed forward variable. So various road conditions such as road angle inclination, amount of water on a road, type of materials a road is made of, so amount of traffic, and then potholes on a road, etc. So next, the classification of the control system. The control system may be classified into number of ways. So some popular classifications, it depends on the methods of analysis and design. So the linear control system and non-linear control system. So what is a linear control system? It obeys the superposition theorem. The principle of superposition theorem includes two important properties. So one is the homogeneity and another one is additivity. So what is the homogeneity? Is a system is said to be homogeneous if we multiply input with some constant, then the output will also be multiplied by the same value of constant. Next, what is the additivity is, suppose we have a system S and we are giving the input to the system as for the first time and we are getting the output as B corresponding to input A. So on the second time we are giving input A and corresponding to this we are getting the output as B. So now suppose this time we are giving the input as A, summation of our previous inputs, that is A plus A, and corresponding to this input, suppose we are getting the output as B plus B. So we can say that the system S is following the properties of additivity. So next one is another classification of control system. It depends upon the types of signal. So time varying system and time invariant system. So the time varying system is the parameter vary with time is known as time varying system, whereas in the time invariant system means it does not vary with time. So next, another classification for a control system, it based on the structure or control action. So open loop control system and closed loop control system. So next one is it depends upon the input and outputs. So what is the, suppose the input and outputs are single input single output means that is a classification for SISO system, whereas in the multi input multi output means it is a MIMO systems. So next, what is the control system? I will explain what is the control system. So control system, not the control system, what is the open loop control system? So first here I am giving the input, the process will be there. So this is the output. So this is called one of the open loop control system. But in a desired output response is actuating device and then process and then this is your output. Okay, so these are all the block diagram of open loop control system. When the input signal is directs the control element to respond, and output will be produced. Example, washing machine, light switches, gas oven, etc. So next is some of the practical examples in your day-to-day life. So first one is a electrical hand dryer. So hot air comes out as long as you keep your hand under the machine. So irrespective of how much the hand is dried. Okay. So next one is a automatic machine, washing machine. So it runs according to the preset time, irrespective of washing is complete or not. So next one is the bread toaster. So it runs as per adjusted time, irrespective of toasting is completed or not. So next one is the automatic tea coffee maker or tea or coffee maker. So the function for pre-adjusted time only. So the next one, the light switch. So the lamps glow whenever light switch is on, irrespective of light is required or not. The final one is stereo system volume. So the volume is adjusted manually irrespective of output volume level. So these are all the some of the practical examples of in your day-to-day life. So next, advantages for open loop system. So simple in construction and design, economical, easy to maintain, generally stable, convenient to use. So next, some of the disadvantages for open loop systems are so inaccurate, unrealizable, and any changes in the output cannot be corrected automatically. So next one is a closed loop control system. It utilizes an additional measures of the actual output to compare the actual output with the desired output response. The measure of the output is called the feedback signal. So here the measurement is, this is a measured, so this is a feedback signal. When I compare this feedback signal with the desired output, and then this output is given to the controller, so controller will take action. So this action is sent to processor. Okay. So this is a closed loop control system. Some of the practical examples for closed loop control systems are automatic electric ion. So heating element controlled by output temperature of the ion. Next one is the servo voltage stabilizer. So the voltage controller operates depending upon the output voltage. So next one is a water level controller. So it works like a input water is controlled by water level of the reservoir. So the next one is a missile launched and auto tracked by radar. So the direction of the missile is controlled by comparing the target and position of the missile. So next one is the air conditioner. The function depends upon the temperature of the room. So it function depends upon the temperature of the room. The last one is the cooling system in car. So it operates depends upon the temperature which is controlled. So these are all the some of the examples, practical examples of closed loop systems. So next one is the advantages. It more accurate. The high accuracy as any error arises is corrected due to presence of feedback signal, large bandwidth, facilitates automations. So sensitivity of system may be made small to make system more stable, so less affected by noise. So some of the disadvantages for closed loop systems are it is costlier, so it complicated design, so it requires more maintenance, and also its feedback leads to oscillatory response, and this one is overall gain reduces due to feedback. Finally, the stability is the major problem and more care is needed to its design. So next, comparison between open loop and closed loop system. So in a open loop system, the feedback element is absent, whereas in a closed loop system, the feedback element is always presented. The error detector is not presented in open loop system. Here the error detector is always presented in closed loop system. It is stable. It may become unstable for closed loop system. In a open loop system, easy to construct, but in a closed loop system is complicated construction. Next one is the economical for open loop, and then closed loop is very costlier. So whereas in the open loop system, it has a small bandwidth. In a closed loop system, it has a large bandwidth. In a open loop system is inaccurate, and this will be a closed loop system is accurate when. So it needs less maintenance for open loop system. So whereas in the closed loop system is more maintenance and also reliable. So for an open loop system is unrealizable. So example for open loop system means hand dryer, tea maker. So there is a etc. These are all some of the examples. Whereas in the closed loop system example is servo voltage stabilizer, perspiration, etc. So next one is what is a feed forward and a feedback control system. The feed forward control system sends information about a disturbance to the control before it affects the process, hence referred to as predictive control. So whereas in the feedback control system, so it takes the process output into consideration, which enables the system to adjust its performance to meet a desired output response. It is also called as reactive control. So next, the comparison between the feed forward and feedback control system. The feed forward control system is a corrective action is taken before disturbance affected the output, whereas in the feedback control system, which corrective action is taken after disturbance affect the output. So it's the feed forward control. The variable are adjusted based on the prior knowledge and prediction, whereas in the feedback control system, the variables are adjusted depending upon the error. So the next one is a feedback control system. Not a feed forward control system. Is a corrective action is taken before the disturbance enter into the process, whereas in the feedback control system takes a corrective action only after the disturbances has affected the process and the generated an output. So it does in a feed forward control does not affect the stability of the system. A stable system without feed forward control will remain stable even after including one. Whereas in the feed forward, that is not the feedback control system, may create instability of the system. Feed forward control system predict the output as it does not measure the output, also called as predictive control, whereas in the feedback control is a react only to the process error. That is a derivative, that is a deviation between the measured output value and the set point. So it is called reactive control. So for a feed forward control, control does not check how the adjustment of input worked in the process. So it is referred to as open loop control. So whereas in the feedback control, the control measures the output and verifies the adjustments results. So it is called as closed loop system. So next one is a servo mechanism. This is a servo mechanism block diagram for the control system. So the servo mechanism is a preliminary consisting of three basic components. One is a controlled device, output sensor and feedback systems. So this is a controlled device. So next one is a four major component for servo mechanisms are motor, gear linkage, position sensor and motor control elements. So motor control control electronics. This is the major component of a disassembled servo. So the automatic closed loop control system, the primary task of a servo mechanism is to maintain the output of the system at the desired value in the presence of disturbance. So a small DC motor will rotate with high speed, but the torque generated by its rotation will not be enough to move even a light load. If this is where the gear system inside a servo mechanism comes into the picture. The gear mechanism will take high input speed of the motor, and at the output we will get an output speed which is slower than the original input speed, but more practically and widely applications. So the applications of servo mechanism includes their use in automatic machine tools, satellite tracking antennas, celestial tracking systems on telescopes, automatic navigation system and anti-aircraft gun control systems. So next one is a multi-variable control system. So MIMO process. So each here this is the desired output. Here this is a comparison, that is a error. The summer, this is the controller, this is the actuator and then process and then sensors. So here not only one input variables, here having more than one, that is a multi-variable, and then controlled more than one also. So the each manipulated variable can depends on two or more of the controlled variable. Examples, a heated liquid tank where both the level and the temperature shall be controlled. A robot manipulator where the position of the manipulators, that means arms, shall be controlled. These are the references I referred for preparing this video lecture. Thank you for watching this video.